Hello students. In the last video, we discussed about the stability of the carbocations, carbanions, free radicals, and stability of the molecules and ions. Now, in this video, we will discuss about the acidity of the phenols. The phenol is nothing but here aromatic alcohol. So first, compare with the aliphatic alcohols and phenols. So which one is more acidic in nature? We will discuss now. Now, first in this. ROH, alcohol. It is aliphatic alcohol. Next, one OH group is attached to the benzene. It is called phenol. It is phenol. It is aromatic alcohol. This one is aliphatic alcohol. It is alcohol. Now, in these two, so which one is more acidic? So the acidic strength of the given compounds depends on the releasing of H plus ion or donating of H plus ion capacity. So after donating of lone pair of electron to this oxygen to benzene, this one, after donation of this lone pair of electron, now this one easily release the H plus ion. But if you observe in this case, this lone pair of electron present on the oxygen, it is not involving in the resonance with the alkyl group. So compared to here this group release the or increases the density on the oxygen. But here the density decreases by this benzene ring or the phenyl ring. So this group withdraws electrons from the oxygen. Here density decreases. The bond strength in between the oxygen and hydrogen is decreased. So it easily release the H plus ions. Now phenol easily release the H plus ions. Now compared to these two, so phenol is always more acidic in nature. Okay. Next, after that, compare with water molecule H, OH, and pH, OH. In these two cases, here pH ring, again this group alone it acts as again minus I group only. This group alone it acts as minus I group. What about this hydrogen? This one acts as a neutral. So neutral and minus I, again this one only more acidic. So now compare these three. Alcohols are less acidic than the water. Water is less acidic than the phenol. So these are the general conditions. Okay, general conditions only. If you observe in the given condition of another one, when phenol is reaction with it is a phenol. Next, cyclohexanol. Okay, the compound name is cyclohexanol. It is phenol. In these two, which one is more acidic? Compared to this case, again, this one is more acidic than the cyclohexanol. So why this one is more acidic? So due to resonance possible in this case, it donates the lone pair of electron to this benzene. But here, this complete group acts as the electron releasing group. Okay, this group alone totally acts as electron releasing group. Here, this group alone it decreases the electron means it acts as the electron withdrawing, but in this case it acts as the electron releasing group. So that's why here, so this one donate the electrons here density increases more, but here it decreases the density on the oxygen. Next, another case. It is phenol. Next, CH2OH. Now compared to these two cases, which one is more acidic compound? It is a phenol. This one, benzyl alcohol. Benzyl alcohol. So in these two cases, again, phenol only more. Why? Because if this oxygen directly attached to the benzene, a resonance effect is possible or mesomeric effect also possible, conjugation. But in this case, the phenol group is not directly attached to here OH. Okay, that means it acts as a minus I group. So compared to here resonance are the mesomeric conditions. Here this group is the minus I, less effectively withdraws electron. So that's why here now this one is a more acidic than the adjacent condition. Then next, if electron releasing group and a withdrawing groups may attach to the phenol, so what are the acidic strengths of the given compounds? We will discuss now. This one is phenol, first compound. Next, second one. It is also phenol. One electron withdrawing group is attached. Electron withdrawing. So just I'm showing this one is electron withdrawing group, not about the complete it is ortho position. Just one group is attached to this one. Next, C, phenol with one electron releasing group. Now in these three cases, which one increases the acidic strength of the phenols? That is very, very important here. If here one electron withdrawing group means, what about the density on the oxygen? Decreases. If electron releasing group is present, it increases the density on the oxygen. So if the density increases more on oxygen, the strength in between the oxygen and hydrogen increases. But in this case, if electron withdrawing group is attached to this, here the strength decreases. Oxygen hydrogen strength decreases. So it easily releases the H plus ions. Now, if any electron withdrawing group is attached to the given phenol, that is always more acidic than the A, compound A. Why? Because there is no electron withdrawing or releasing groups present on the compound A. It is a neutral compared to these two. It is neutral. So first, electron withdrawing group containing phenol is more acidic than the A. A is more acidic than the C. So this one is the acidic strength of phenols. This is the acidity of phenols. Okay. The next another cases. So in this we will discuss same as like if any group is attached to the phenol at ortho and para positions and meta positions. So how we can identify the acidic strength of the phenols? We will discuss now. Next example here. First, so I will give the conditions here. Electron releasing group or withdrawing group means if a minus M or minus I group attached to the phenol. Minus M minus I, it is directly relation with the acidity, this one. If plus M or plus I group is attached to the phenol, it is inversely relation with the acidity. So these two compounds very, very important. So plus M plus I is electron releasing groups, minus M minus I electron withdrawing groups. So electron withdrawing groups always increases the acidity. Electron releasing groups always decreases the acidity. So these are the conditions. Now, the first example, first one A, first one is phenol group. Next, second one B, phenol attached to one group, it is CH3. CH3 at a para position. The next, third compound, same phenol group only. Here, para position, one OCH3 group is attached. Next, D. one OH, here NO2 group. Now, in these four given compounds, so which one is the more acidic compound? So how to identify that acidity, acidity of the given phenols? So in the first case A, here there is no group is present. Here there is no group is attached to phenol. But in the second case B, one CH3 group is attached to the para position. So if CH3 group is attached to phenol means here hyperconjugation only present. Hyperconjugation. Then coming to the C, OCH3 group. So here OCH3 group means two lone pair of electron present on the oxygen. Now this group acts as a plus M group. Next coming to the D, here NO2 group is attached to the benzene directly. Now minus M group only present. Okay, in these all cases, hyperconjugation means it release the electrons. Now plus M means also it release the electrons. Here compared to these two releasing groups, here neutral atom hydrogen present, but minus M means it decreases the density on oxygen. Now, which one is more acidic in these all cases? Electron withdrawing groups always increases the acidic strength. So the first option is D is more acidic than the remaining all. After that, B and C both are the electron releasing groups. So A is the more acidic. A is more acidic. Next, DA after that in these two, effect and hyperconjugation. Mesomeric effect is more dominant. So more effectively release the electrons means it is the least acidic compound. Here the density increases more. So oxygen hydrogen strength increase. So the bond strength increases means it is unable to release the H plus ions. So C is least, B is greater than the C. So this is the order of acidic strength of the phenols. Okay. So next, another example. Next example is this is the phenol compound A. Next compound B. Phenol or the position one NO2 group is present. Next, meta position same NO2 group is present. Para position one NO2 group is present. Now in these four compounds, so identify the acidic strength of the compounds. So first, simply identifying this, it is a neutral compound. Here one NO2 group is attached at R the position. Here minus M group is dominating than the minus I. Why? Because here NO2 group only attached to the all positions. Now here also one NO2 group is present at meta position. If any group which is attached to the meta, always here minus I group only present. There is no mesomeric effect. Now coming to the compound D, here also this one minus M group is present. It is dominating more than the minus I. So in all these three B, C, D cases, minus M, minus I, minus M, all are the electron withdrawing groups. So A is neutral compound. Compared to these three, A is the least acidic. Okay, we can say directly A is the least acidic. Now coming to the B, C, D conditions. Now B minus M group, D also minus M. So inductive and minus M, which one dominates more always? M, mesomeric effect only always dominating more. So these two groups always more acidic than the C. Okay, this one also confirmed. Now C is more acidic than the A. It is confirmed. Next B and D. Which one is a more stable? That one we have to identify. So how to identify the acidic strength? If a phenol group or the position, it has one NO2 group minus M. Here also minus M. Para position also one minus M. So minus M means mesomeric conditions are equal in both cases, B and D. The next go through the inductive effect. Inductive effect. Here also minus I group is present. Here also minus I. In this ortho and para position, so which one must decide the acidic strength? Distance. So now in compound B, the NO2 group is very near 1 comma 2 position. But if you observe in the compound D, 1, 2, 3, 4, distance here increases. If distance increases, inductive effect is decreased. So which one more acidic now? B is always more acidic in this case. So B is more acidic than the D. D is more acidic than the C. C is more than the A. This is the order, acidic strength order of, in this case, this one. Next, another example we will discuss. A, here phenol, B, phenol with one CH3 group at ortho position. Next, C, phenol, para position, one CH3 group is present. Next, D, phenol, meta position, one CH3 group is present. In this given condition, A is always neutral one only. Then coming to the B, one CH3 group which is attached to the ortho. So ortho means first hyperconjugation dominates more than the which group? Inductive plus I. Next, here also one CH3 group is attached to the phenol at para position. Here also hyperconjugation dominates more than the inductive. Okay, inductive group. So hyperconjugation more than the inductive. Here one CH3 group which is attached to the meta position. So meta position, if any group is attached, always inductive. In that CH3 group acts as a plus I group only. Now, these all are the releasing groups only. So B, C, D, all are the releasing groups. Releasing groups always decreases the acidic strength. So decreases means which one is more acidic now? A is more acidic than this B, C, D. Now in this again, which one more acidic? Hyperconjugation means sigma electrons donates. Here, this complete group only donate the electrons. So next acidic strength compound D. After that, hyperconjugation is common. Next to go through the inductive effect. So based on the distance, if distance is very high in C, it is less effectively release electrons. Next, C is more acidic than the B. This is the order. So this kind of problems also very, very important. Then next, after that, we will discuss few more examples in this. In that, next example is phenol. Here one CH3 group is attached. Next B. Here one CH2 CH3 group is attached. Next C. Phenol. Here CH bond CH3 bond CH3. So isopropyl group this one. Next compound D. Here phenol bond CH3 bond CH3 bond CH3. So here tertiary butyl group. Now in these given four compounds, which one is more acidic? So in the compound A, one CH3 group is attached to the meta position. One meta position, one CH3 group is present. It acts as a inductive. Here also one group is attached to the meta position only. This group also acts as a inductive. Now here one isopropyl group is attached. It is also inductive group. Here one tertiary butyl group, it is also plus I group. So if any group which is attached to meta with respect to given phenol compound, always these groups act as a inductive plus I groups only. So which one effectively release the electrons? It is only methyl group. It is a primary group, secondary group. It is a tertiary. So which one effectively release the electrons? This tertiary group only effectively release the electrons. Then what about the density on the oxygen? Increases more. So if it is increases more on the phenol, now the acidic strength is very less. So the acidic strength order for this A is greater than B, B is greater than C, C is greater than D. This is the acidic strength order of this kind of molecules. This is very, very important. The next, another example we will discuss now. Same as like first compound, phenol with one CH3 group attached to the para position. Phenol, one CD3 group is attached to the same phenol. Next, OH1 CD3 group is attached at a para positions. In these three cases, so which one is a more acidic compound? Now, here CH3 group, hyperconjugation is present. CD3, again hyperconjugation is present. Hyperconjugation only present. Here the CDT, these all are the isotopes of the hydrogen. For this kind of compounds, which one has more acidic strength? How to identify that? Here hyperconjugation is dominates more than the inductive. Here also inductive groups. But the inductive group also here more present in the CT3, CD3, CH3. First hyperconjugation is common in all cases, but H3, D3, T3. Now these compounds depends on the carbon hydrogen bond strength. Okay, bond strength. Which one is more bond? CT bond strength is very higher than CD. CD is higher than the CH. So this is the bond strength order of the given carbon hydrogen, carbon hydrogen, carbon, carbon tritium, carbon deuterium, carbon hydrogen bonds. If the strength is very high in between the carbon and hydrogen, what about the bond dissociation energy? Bond dissociation energy. Which one required more? Again, CT required more energy than CD than CH. So if this one required more energy to break the bond. So in these three cases, which one easily breaks? Carbon hydrogen bond will easily breaks. So if carbon hydrogen bond easily breaks means this that reactivity is very high means that one increases the density very high. If the density increases more on this carbon, now the acidic strength is less. Acidic strength is less only. So that time which one is more acidic in these three cases? C is more than the B, B is more than A. This is the acidic strength order of the given phenols. It is very, very important. Here bond strength, bond dissociation, energy. So for this kind of conditions, bond dissociation energy only important. Then next, another same kind of one more example we will discuss now. Same phenol group, CH3 group at meta position. Next, compound B, phenol. Here one CD3 group is present. Compound C, one CT3 group is present at meta position. Now, for this kind of cases, so how to identify the acidic strength? Now, one CH3 group is present at meta means again it is plus I group. Now, CD3 attached to the meta position means again it is plus I group. CT3 also attached to the meta means plus I group. So, in these three cases, which one more effectively release the electron? That is also important. Distance also same in these three cases. But if the mass increases, that one more effectively release the electrons. Already we discussed this one in the plus I group order, plus I effect order. So CD3 more effectively release electrons means here density increases. So it is unable to release the proton. So the acidic strength is very less in C. Now which one more acidic? A is always more acidic than the B. B is more than the C. In the above case, C is more than the B, B is more than the A in this case here. But here it is reverse. Okay, if inductive effect considered, CT3 more effectively release. In hyperconjugation condition, CH3 more effectively release the electrons. Okay, in the next video, we will discuss about the acidic strength of the aromatic carboxylic acids. That means benzoic acid. That is a very, very important, and exceptions also we will discuss in that. Thank you.